Hey guys, RLA Jack here with another Cam 210 video, and in this video I'm going to show you the way of the while loop. In the last video we looked at the for loop, and the for loop allows you to iterate through a list of things, or a list of numbers, setting a variable equal to it each time, or you can also just use it to run something a bunch of times. A while loop also lets you run something a bunch of times, but it has this sort of built-in conditionality that lets you essentially run something until it meets or breaks a certain condition. So I wrote this little piece of code to demonstrate a very basic while loop. So I have this variable a, and essentially while a is greater than 1, so while this is true, it is going to take a, it'll divide it by 2, and it'll keep on doing it until a is no longer greater than 1, at which point this while loop will end, and any code down here, let's just say display I'm done, and that will run. So if we run this while drive, you can see it goes from the first time you divide to 33, and 16.5, 825, 41250, and so forth, until it reaches a number that's smaller than 1, and then it says it's done. Okay, so that's a really simple while loop. But why not a for loop? So the main reason for why not use a for loop is that we don't know the number of times that a has to divide to become less than 1. And because of that, a for loop is a lot less useful. We could come up with some messy formula, I think we can do log of a over log of 2 plus 1 is equal to n, something like 4I is equal to 1 colon n, a is equal to a divided by 2, and maybe this will work. And yeah, that does. So you could come up with some formula that would analytically tell you the number of times that you need to divide, but a while loop is more convenient because you don't have to add this formula. A while loop will just figure out what it needs to do while it's doing it. And that's the main reason that while loops are advantageous in many cases. Next week, you'll be looking into a method called the bisection method, and it essentially has this error, this numerical error in finding the root of a function, and you're going to have a certain tolerance on that numerical error, and you will essentially keep on refining and getting a better estimate of the root of a function until that numerical error is small enough that you're happy and can stop. So instead of while a is greater than 1, you'll say while numerical error is not good enough, or numerical error is greater than something. So yeah, that's pretty much all there is to say on why while loops are great. You can also use a while loop as a counter. You could do something like CTR is equal to 0 while CTR is less than 10 or less than 5. Display cam is good. And then you might do CTR is equal to CTR plus 1 end. And this is just another way to do something a bunch of times. So this while loop here does the same sort of as a for loop, spitting out a bunch of stuff here. But instead, this while loop is actually more efficient on memory in the computer, because instead of creating a huge vector and just using that vector only for the number of elements in the vector, and wasting all that information, we only keep one counter variable, and we just use that counter to count every time that we perform an action until we have performed enough actions. Okay guys, so that's it for while loops, and yeah. Okay.